Hello, fifth graders. This is for any of you who maybe missed the Zoom on Monday, December 14th. So missed Zoom 12/14. Or maybe you just liked the lesson so much you want to watch it again. Anyhow, we did start off reviewing the phases of the moon with our little diagrams here, our models. And we have the sun, of course, and the earth, and here's the moon. And we reviewed the fact that this is phase one right here. The sun is shining. Right now it's hitting this part of the moon. If we're standing right here, we only see total darkness because the moon is not a source of light. It reflects the light from the sun, and the sun can't go through the moon here. So this would be new moon. This means we look up in the sky and we see total darkness. Now, as the moon travels counterclockwise around the earth, up about 45 degrees, right now light would be hitting this much of the moon. This would be total darkness. So if we're looking here, all we end up really seeing is a tiny little sliver on the outside here. And that would be called a waxing crescent. Waxing, again, means increasing. So we just went from seeing nothing to seeing a sliver. That means it's getting larger, waxing. When the moon is in this position from the earth, now we have this side completely lit up and this side's in complete darkness. As we're looking straight on, to us it looks like we see half of the moon. But really, since we're not seeing the back and we're only seeing this much lit up, we're only seeing 1/4 of it. So we call this first quarter. This is first quarter because we are seeing 1/4 of the moon, even though it looks like a half moon to us. All right, we travel another 45 degrees over here. The sun is shining on this part of the moon. This part's darkness. Now we see kind of a lot of the moon lit up. Not the whole thing, but a lot of it. So this is called waxing gibbous, again, because we're seeing more and more of it. So it's waxing, getting larger. And it's not a full moon yet. It's a gibbous because it's still about that much of it's covered. Now it heads over here and the sun is shining. The earth isn't actually blocking it. The moon isn't directly parallel with the earth. So it's this whole entire part is lit up. So this, even though we're only seeing half of the moon that's lit up, to us it looks like the whole moon is full. Because this isn't actually 2D, it's 3D, right? So this whole side would be filled up. So there's our full moon. Now we're gonna kind of work backwards. As it heads down here, this part's dark, but this whole side's lit up from the sun. And now we have a waning gibbous. We're seeing not the whole moon, but we're seeing a lot of it lit up. But it just went from us seeing the whole thing to now not the whole thing. So it's getting smaller. It looks like it's getting smaller. It's really not. It's just that's the part that's lit up. So it's waning gibbous. All right, now as the moon heads down here, we're not seeing the whole thing. We're seeing half of it. But what we're really seeing is 1/4 of it because we don't see the back. So this is called the last quarter. Up here was the first quarter. This is the last quarter. And we are only seeing 1/4 of it, even though it looks like half. We continue around. Again, this side's all darkness, this side's lit up, but if we're standing here looking on, we're only going to see this little crescent, but this is called a waning crescent because we're seeing less and less. It's decreasing, and that's what waning means. And then we're back to the beginning. We're seeing total darkness again. That is phase one again, the new moon. Again, this whole process takes about 1 month for the moon to make it all the way around the earth. Okay, so that was our review that we started with. We then moved into social studies and we looked at sections 4.1 and 4.2. So go ahead and grab your social studies book and you can follow along. We did read the text together, so I'll read it out loud to you now. We're on page 39 in our book, page 39. So I'm gonna go ahead and read these out loud to you. And you can follow along, or you could read it out loud too if you want. I won't be able to hear you though, I'm very sorry. All right, so follow right along. Chapter 4 is why Europeans left for the New World. And basically, we're going to talk about explorers and them coming to the Americas. So what the introduction says, in Chapter 3, you read about Native American cultural regions. In this chapter, you will learn why Europeans sailed to the Americas, which they called the New World. Of course, to Native Americans, this was not a new world. They had lived here for thousands of years. So the Native American peoples are already settled in. And around the 1500s, that's when all of these, it was the age of exploration, you'll see in the next paragraph. They started coming over and maybe disrupting some things. As we get further along, you'll kind of see what took place. But they called it a new world. The Europeans called it a new world because it was new to them, but it wasn't new to the Native Americans that were already living there. The 1500s were the age of exploration for Europeans. Prior to this time, only a few people had traveled very far from Europe. They couldn't hop on a plane. They couldn't take a nice cruise. They had kind of small ships that they would sail, and there weren't really maps that were all set yet. So when these people were exploring, they just headed out kind of not knowing what to expect. So before the 1500s, not a lot of people wanted to do that. That was quite risky. Beginning with Columbus's famous voyage to North America in 1492, Europeans wanted to search lands unknown to them. Explorers sailed small ships across large oceans that few had crossed before. So again, they're going places they've never been in search of some new things, and we'll talk more about those new things in our next chapter. All right, next paragraph. Ocean storms and rocky shores sometimes destroyed their ships. Today, people find and excavate, or dig up, that's what excavate means, such sunken ships. They look for artifacts such as tools and gold coins on the nearby ocean floor. These objects reveal why explorers sailed to the new lands and what they found there. And again, in the next chapter, we will talk a lot about why. Why would they, leave the comfort of where they're at to go exploring places they had no idea about? It could be risky, it could be dangerous. A lot of them left their family, left their friends to go and do this. So right now it's kind of setting the stage for our next chapter. Look at the drawing of the sunken ship to the right. As you read this chapter, imagine that you are a diver investigating a sunken ship to learn about European exploration. What objects might you find? What clues do they give about why Europeans came to the continent of North America? And that's basically what happened. Archaeologists investigated these sunken ships and found various artifacts that were left behind. And that's how we're able to give you this information. All right, you can turn the page. We also went through section 4.2 today. Underwater archaeology. Archaeologists often look for sunken ships in order to understand the Europeans who first explored the Americas. To find a sunken ship, archaeologists examine old ship records kept by European merchants. They read tales from shipwreck survivors. Sometimes they use machines to help find a ship's anchors or cannons. For example, sonar is a technology that uses sound to locate sunken objects. That's one of your vocabulary words for today. It's not in your glossary. You'll have to take it right from here. So sonar is a technology that uses sound to locate sunken objects. Archaeologists need to know the location of each artifact on a sunken ship. So divers mark off the site in squares with cables or plastic tubing, similar to a coordinate plane in math. Using this grid, they can carefully record each object's location. This information will help archaeologists decide who probably used the objects for what purposes. Each artifact must be photographed, brought to the surface, tagged, recorded on a list, and cleaned. Metal artifacts usually survive the longest. Objects made of plants or animal products may disappear. It's the same with us. Like when we throw away maybe the core of an apple, that doesn't last forever and ever. Eventually it's going to decompose. So objects that were made of metal, those, were less likely to decompose than these other plants and animal products, right? After studying hundreds of artifacts, archaeologists may be able to tell the name of the ship, where it was going, and why. Perhaps even who was on it. Finding a sunken ship often takes many years. Bringing up the remains can take weeks or even years. Understanding what the objects mean takes even longer. Read on to learn about the artifacts that give clues about why Europeans sailed to the New World. And we're just going to focus on, I think, 8 of them in this chapter. There were more artifacts that were found, but we're going to look at the big 8. Okay, so that's what's going to be happening for the rest of this week. We'll end up finishing chapter 4. All right, that's all we read for today, and then your job was to complete your social studies vocabulary in your assignments. So far we have science. You're going to be doing the phases of the moon today, labeling those. And for social studies, you're going to be going ahead and doing your vocabulary words for chapter 4. In math, we did 5 problems today. We did 5 word problems to help us get prepared for tomorrow's test. These 5 word problems are located in the materials you need for whole and small group in today's assignment tab. So we'll work through these together, and as always, you can work through the problem and then press play and see if your answer matches. Barry walked 3/4 of a mile to his friend's house and then another 1/8 of a mile to the park. What is the total distance he walked? Well, I know when I am asked to find a total, it means I'm going to add. So I need to add 3/4 plus 1/8. Now I will tell you there's a couple ways to solve this. A lot of my students today went ahead and used the LCM and multiplied 3/4 by 2/2 because they saw that that would give us 6/8, and I can add 6/8 plus 1/8. That would give me 7/8 of a mile. So it would take 7/8 of a mile. Another option people used, they took the 3/4 and they multiplied that by 8/8 and then 1/8 by 4/4. If you do that, you'd get 24/32 plus 4/32. I don't know why I just wrote a 4. 4/32. And 24 plus 4 is 28/32. So 28/32 of a mile. Now, both of these are correct. 7/8 is best because it's in simplest form, but these are equivalent. I could do 7 times 4 to get 28, 8 times 4 to get 32. So either is acceptable. 7/8 would be simplest form though. All right, number 2, of the songs downloaded from a music site on Tuesday, 1/6 were country songs and 7/10 were rock songs. What fraction of the songs were country or rock? So if I want to know what fraction of the songs were country or rock, that means out of the total, I want to know country and rock together, combined. We're adding these. When you see that word or, and it means one or the other, that means both of them apply. It's usually addition. So 1/6 plus 7/10. And again, I'll show you the 2 ways people solved this. I had some students that used the LCM. The LCM of 6 and 10, the least common multiple, is 30. To make 6/30, I would multiply it by 5, and to make 10/30, I would multiply it by 3. So many people solved 5/30 plus 21/30 to get 26/30. Now, 26/30 is correct. I did have some individuals that said, hey, Mrs. Trombley, these are both divisible by 2, so I could simplify that. 26 divided by 2 is 13, and 30 divided by 2 is 15. And I will tell you that 13/15 is also correct. This is the best answer right here, 13/15 of the songs. Now, other students solved 1/6 plus 7/10 and did not use the LCM. They just multiplied each fraction by the opposite fraction's denominator, which you can do. You would get 10/60 plus 42/60, which would give you 52/60, which is also correct. So all 3 of those answers are correct. 13/15 would be the best way to say it. All right, number 3. Amy used 13/15 of a yard of ribbon in her dress. Jasmine used 9/10 of a yard of ribbon in her dress. Which girl used more ribbon? How much more did she use? There are 2 question marks here because you have 2 questions to answer. The first one is which girl used more. That means I need to compare 13/15 and 9/10 to know which is more. So that would kind of look like this. Now, I did kind of push everyone towards the LCM for this, so I wouldn't recommend multiplying this by 10/10 and this by 15/15. The first number that 15 and 10 would have in common if you counted by them is 30. 15 times 2 is 30, and 10 times 3 is 30. So 2 times 13 is 26/30, and 9 times 3 is 27/30. So now we have the same denominator, and I know that 27/30 is more than 26/30. Jasmine was the one with 9/10, so for which girl used more? Jasmine used more. And it wants to know how much more. So if I want to know how much more, that means I want the difference between the 2. So I would take the higher value minus the lower value to get 1/30. So Jasmine used 1/30 of a yard more. If you did it the other way, you'd get 5/150, which isn't wrong, but this is definitely a lot simpler way to write it. Okay, number 4. Every week, Mr. Park asks for 1 pound of turkey at the deli. The line plot shows the actual weight of the turkey the deli worker has given him for the past several weeks. It's really hard to get right on the mark. What is the difference between the greatest and least weights that Mr. Park received? So first thing you have to ask yourself is, what does difference mean? What operation? Now, whenever you're trying to find the difference between two items, that means you need to subtract them. You want to know the difference between the two. So it says between the greatest and least. When you're looking at a number line, the value that is farthest to the right is going to be the greatest. So the greatest weight that Mr. Park was given is 1 and 5/32. That's the highest value. I'm going to take away the lowest value. Now I know on this it looks like 0 is the lowest, but 0 never happened. There's not a dot above it. So the next lowest would be 31/32. So our job is to find the difference between these two. We have to subtract. I can't take 31 away from 5, so I would need to borrow. That means I need to add 32/32. So my new fraction that I'm dealing with is 37/32 minus 31/32. 37 minus 31 is 6. And if you wrote down 6/32 of a pound, you're correct. You could also simplify this though. If you notice, hey, those are both even. I'm going to divide them both by 2. Then you got 3/16 instead. That looks like part of one thing. 3/16 of a pound. Both of those would be correct on your test. 3/16 is the best way to say it. That's simplest form. That's what I want us to always be working towards this year. All right, number 5. Nora read 1/9 of a book on Monday and 3/7 on Tuesday. What fraction of the book does she have left to read? Okay, so let's think this through. Sometimes when I'm not sure where to start, I'll draw a little picture. So here I have a book, and I'm not going to draw this to scale. I'm just going to use a little visual diagram to help me out. It says Monday she read 1/9, and Tuesday she read 3/7, and then I want to know how much does she have left to read. So that means I want to know what this is. So usually a diagram like this gives me a starting point, and I would say my starting point is to figure out how much has she already read. That means I need to add 1/9 plus 3/7. When I do that, I need to multiply each fraction by the opposite fraction's denominator, because the LCM is 63. So 7/7, 9/9. I would have 7/63 plus 27/63. When you do that, you'll get 34/63, which is not my answer. This is how much of the book she's already read. Our job is to figure out how much she has left to read. Now, normally when you think about a book, you'd say I read 1 book, right? Well, in this case, 1 book would mean 63/63, because if I'm trying to take 1 minus 34/63, I would need a common denominator. So in order to figure out this question mark, I could ask myself 34/63 plus what equals 63/63, or I could subtract 34/63 from 63/63. Either will give you the same answer, because addition and subtraction are inverses. So 63 minus 34, that is 29. Our denominator stays the same. So she has 29/63 left to read. And now you're all caught up. Talk to you soon.